Good afternoon, everyone. This is BremSter, and today I'm coming to you with a puzzle called Counting Stars by GoodCity. The name GoodCity is familiar, and I'm not sure if I've solved a puzzle by them before, but these puzzle rules seem quite daunting, so I'm pretty much going to get straight into it. The fastest tester I had for this was over half an hour, so I'm going to see how I go. So, normal Sudoku rules apply. So in every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. Digits joined by a white dot must be consecutive. Digits joined by a black dot must be in a 1 to 2 ratio. Not all possible dots are given. So that means that there will be consecutive dots cells somewhere, pardon me, and there will be cells with 1 to 2 ratio somewhere that aren't given by dots. Now comes the tricky bit. Digits placed on dots read left to right or top to bottom, so left to right for these and top to bottom for these is the way I'm seeing this, indicate the coordinates of the sum of those digits. If the sum is greater than 9, subtract 9. All coordinates given by dots are unique. Now, there's no example above, but there is in the description and in the puzzle rules. E.g., if row 7, column 1 is a 6, and row 8, column 1 is a 7, 6 plus 7 is 13, 13 minus 9 is 4, and therefore row 6, column 7 must be 4. Now that is incredibly daunting to me, because the chance of just subtracting 10 is, and I understand, yeah, this is going to melt my brain, but we'll see how we go. They're the rules. Anyway, I've been getting more and more people watching my channel not subscribed. If you're not subscribed, please do. And please video, like, comment, all of that sort of stuff. I hate having to say that, but YouTube keeps prompting me to. Let's give this a shot. I have restarted the puzzle. There's links below to the puzzle and all sorts of stuff. But the important thing is let's give the puzzle a shot. Give the puzzle a try. So, how do I start this? How the heck do you start this? Like, I could sit here and go, okay, I look at this dot and what could it be? And I could go through all the options and I could say, well, if this was 1, 2, then that would say row 1, column 2 would have to be 3, but I'd already put a 1 there, so that doesn't work. And 2, 1 here would be putting in that cell, and it would be saying row 2, column, it would say that's a 3, and that would be fine. And I imagine if I do for the others, then it's going to be pointing outside. So I don't see what the conflict is there. So what do we know? Now, white dots must have an even and an odd number on them, because 2 consecutive digits will be, the digits are next to each other and just numbers go odd, even, odd, even, odd, even. The definition of odd and even is if you divide by 1, they have different divisors. Now, black dots will always have a low digit on them and an even digit on them. So there will always be an even digit on a black dot, because there's only 4 ways of making a black dot with Sudoku digits. Because you've got 1 doubling to 2, 2 doubling to 4, 3 doubling to 6, and 4 doubling to 8. How many black dots do we have? We've got 1, 2, 3, 4, 5, 6, 7. But all of the coordinates are given are unique. So what are the possible coordinate destinations of black dots? 1, 2 can land in either row 1, column 2 or row 2, column 1. So those are possible coordinates. 2, 4 would be row 2, column 4 or row 4, column 2. So it would be those cells. 3, 6 would be row 3, column 6 or row 6, column 3. So it would be those cells. And 4, 8 would be row 4, column 8 or row 8, column 4. So it would be those cells. So they're the only possible destination cells for the black dots. And there's only 8 possible destinations, but I've got 7 dots. So I can never use the same dot combination more than twice. And one of them's only going to get used once. But what does that tell me? Two of them are on black dots. So what are the possible targets? That's a good question. What are the possible destinations? Because 1, 2, the sum is 3. Actually, I'm just going to use these cells here as my sandpaper. So 1, 2, the sum is 3. 2, 4, the sum is 6. 3, 6, the sum is 9. Remember, this is just me making notes. And 4, 8, the sum is 12. 12 minus 9 is 3. So the only possibility, but one of them isn't included. So the only possibility for 7 of these 8 cells is 3, 6, and 9. And these ones, if they were targets, can't be 9. But I could make these 3, 6. And these would then both be 9s. And then this would be 8, 4, which has a 3 destination, and would make that a 3. There's something going on here, and I can't see what it is. Because I only need to fill 7 of those destinations. But 7 of them have to be filled with 3, 6, and 9. But they don't see each other. I can put 4 3s in there. I could put a 3 there, a 3 there, a 3 there, and a 3 there. That would be fine. Because 1, 2, 4, 8 all point, 1, 2, and 4, 8 all point at a 3 destination. So if the dots are 1, 2, I can put a 3 in different places. So I don't have to drop out a 3 destination. One, two, three, four, 5. There's only 7 black dots. If there was 8 black dots, I could mark 3, 6, 9 in all of those and get a deduction. I mean, I can see one of these has to be 3, 6. Because I can only drop 1 out. Now, if this was 3, 6... and 3, 6 points at a 9. And these are the 3, 6 destinations. So one of these has to be a 9. Could they both be 9? If they're both 9, that puts 9... Yeah, I don't see why not. I mean, that'd become 8, that'd become 4. 8, 4 would then put a 3 there. So this would have been the 6. Yeah, I don't see it. There's a very cool thing here that I'm not getting. These being 3, 6, 9, if this one is dropped out, because if this is 3, 6, so this is either 3, 6 or it's not included. If it's not included, all of these become 3, 6, 9, which would make this a 9 and this a 3, 6. Now, if this is a 9, it's pointed to by a 3, 6. Wait a minute, a 9 is pointed to by a 3, 6. But I could put a 3, 6 like down here. Because these... Hang on a minute. If this isn't 3, 6... Wait a minute. If this isn't included, because remember, any one of these cells that is included must be a 3, 6 pair. If this isn't included, this becomes 3, 6, so that becomes a 9. But how do I point to that being a 9? Because the other thing I would have to point to it with is a 3, 6. But this is in 2, 1. And 2, 1 doesn't point to a 9, so this has to be included. So this is a 3, 6. Now, if this isn't included, so this isn't a 3, 6. So we know that one of these is a 9. The question is, that's insane. So this has to be 3, 6 or... No, it doesn't have to be included. It doesn't have to be a target. If it is a target, it's a target of a 3, 6. But it can't be a target of a 3, 6. Or can it? Like, could I put... No, because this is in 2, 1. It can't be the target of a 3, 6. That is not included, and all of the others are. These are all... This could never be the target of anything. Because the only thing it can be the target of is a 2, 1. Hang on, let me run that back again. Which has to be a 3, but it can't be a 3 because this has to be the 3, 6. And I can't put a 3 there. And the reason this had to be a 3, 6 is if this is anything other than a 3... If this isn't included, this is included. Therefore, this has to be 3, 6. And that digit, which is also included, has to be a 9 and isn't pointed to by a 3, 6. So this has to be included. This is not included. And all of these others are 3, 6, and 9. That's crazy. So this is not a 9 because this is also a 3, 6 pair. And these are both 9. So this is a 9. This is an 8. This is a 4. This is a 9. So 9, 8, which is row 9, column 8, is 17. 17 minus 9 is 8. So that's 8. That's 4. So I'm going to mark that that dot is done. That dot is done and that dot is done because one of them is 3, 6 and one of them is 6, 3. I hope I haven't done this wrong, because there is a very strong possibility I have made a huge mistake in this initial deduction because I feel incredibly uncomfortable about it. But let's keep going. So row 4, column 8 is 12. 12 minus 9 is 3. So row 4, column 8 is 3. So this is not 3. And now this dot is done. Okay. So I've used both 3 6s. I've used both 4 8s. So the only thing left are 1, 2, and 2, 4, and they must contain 2s. And one of them isn't, but I'm never using 2, 1. So I need to use 2, 2, 4s. It's the same here, 1, 2, 2, 4. And I'm never using 2, 1 because this cell is not included. I can't point to a 9 because the only thing that sums to a 9 is 6, 3. So this is a 3 or a 6. The 4, 8, row 8, column 4. Hang on, row 8, column 4 is that one. Hang on, why did I got the 4 there from the row 9, column 8, but row 8, column 4 is 12. 12 minus 9 is 3. That's a 3. So this is a 2 or a 4, and it's a 2 because of that. So row 3, column 2, which is that, is a 5. And that dot's done. This is crazy. Now 3 is in one of these two by Sudoku. Now, for the black dots, I can't use 2, 1. I need a 1, 2 that must point to a 3. So hang on. Oh, of course, 1, 2 always had to be a 3. Because 1, 2, the coordinate 1, 2 points to a 3. I could have just done it that way. As soon as I know that 1, 2 was included, 1, 2 is 3. So this is the 3, this is the 6. 2, 4, the sum of those, this is the 6, this is the 3. I should have done it that way. So the 1, 2 and the 2, 4, and I can't use a 2, 1, but I must use a 4, 2. And 4, 2 is also 6. Surely now I've got to do Sudoku. There's a 2 in one of these two spots. There's a 6 on this dot by Sudoku. So this is 5, 6, or 7. Now, if it's 5, 6, row 5, column 6 would have to be 11 minus 9, which would be a 2. That's fine. If it's 6, 5, then row 6, column 5 would have to be a 2. So that doesn't work. If it's 6, 7, though, 6, 7 is 13. Minus 9 is 4, and that would have to be a 4. And it can't be. So this can never be the 6. If this is 6, 5, 11 minus 9 is 2. This would have to be a 2, and it can't be. 6, 7 would mean 13. 13 minus 9 is 4. That would have to be 4, and it can't be. This is never the 6. This is the 6. So we're either looking at 5, 6 or 7, 6. Now 5, 6 would make this a 2, and 7, 6 would make this a 4. which I think is okay. I'm still... I can't use 2, 1. Oh, but I can use 2, 4, and I must use 2, 4. But I can never put 1 at the end of a black dot, because the only way I do that is with 2, 1, and I can't use 2, 1. So there's never a 1 at the end of a black dot. So this is pointing at either that cell or that cell. I think I've done all of these now. I'm going to unmark those. So this... Actually, what I'm going to do is I'm going to change all of those to the same color. I'm going to make them all yellow. Okay, because this is now pointing at one of those 2 cells. What about this? If this is 7, 6, it's pointing here. And that would make that a 4, which would make this a 5. 4, 5 would be pointing there and make it a 9, which it can be. So what am... There's another trick I've missed. Oh, this isn't 4. Because of the 4 in the box. Threes. 3 in this box. That's a 3. Can I do more with 3s? There's no 3 there. There's no 3 there. There's no 3s in those. 3 is in one of those 2. There's got to be more. So either 5, 6 pointing at that, making it a 2, which would make this a 4. And we know 2, 4 is a 6. So that's all good. And we need a 2, 4. The only thing we don't have is a 2, 1. So we need a 1, 2, hang on. So we need a 1, 2, a 2, 4, and a 4, 2. So one of these is a 4. Does that do anything? Well, it means that 4 in box 1 is in one of those 3. No, it doesn't mean that at all. It means that it can't be there. No, I'm missing it. Six is in one of these. Oh, 6 is right there in box 5. So now 6 is in one of those. Can that be a 6? If that's a 6, this would be 6, 5, which doesn't give me a 4 because 11 minus 9 is 2. And if it's 6, 7, that, if this is 6, this is 6, 7. 6, 7 is 13, which would make that a 4. This can't be the 6. This is the 6. Which puts 6 up here. That's unhelpful. So this can't be 2 or 6 anymore. So it's got either 4 or 8 on it. If it's 4, it's 4, 5. And I think we've already proved that could be the case because 4, 5 is 9 and that would be a 9, which is okay. If it's got 8 on it, there's 4 possibilities. And just pecking through 4 possibilities seems terrible. 7, 8 would be pointing at that cell, and it would need to be a 6, which seems fine, because 15 minus 9 is 6. And I've already got now possibilities for this to contain either 4 or 8. So how do I progress? Of the black dots, if this was 1, 2, these both become 2, 4. Is there a problem with that? Not that I can see. What dot haven't I used or seen? Like, this dot has too many possibilities. It could be almost anything. This is the only restricted dot that I can see. This had a beautiful break-in. What am I missing? This can't be 1, 2. It can't be 2, 3. It can't be 3, 4. It can be 4, 5. It can't be, but only in one order. Can't be 5, 6. Can't be 6, 7. Can be 7, 8. So it can only be 4, 5 or 7, 8. Five, 4 makes that a 9. Should put a 9 in one of those two. 7, 8 would make that a 6. 8, 7 would make that a 6, which it can't be. So it can't be 8, 7. So it's either 5, 7. Oh, hang on. And that 4 makes that the 8 and that the 7. I should have seen that before. No, hang on. I just took the wrong ones out when I did it before. Why do I keep doing that? This is the 4. This is the 5. So row 4, column 5 would be the 9. Why do I keep doing that? So that's fine. And this can't be 8, 7, because that would make this a 6. So this can't be 8 and this can't be 7. So 4, 7, 5, 8. And it's pointing at either 4, 5, which is that cell, or 7, 8, which is that cell. And that cell has to be 6, or that cell has to be 9. Maybe my initial deduction was wrong. Maybe my initial deduction was wrong, because I'm not seeing any progression on this. Apart from casing this dot over and over and over, because the black dots are accounted for. 1, 2 is going to point at 3, 2, 4 is going to point at 6, and 4, 2, whichever one of these is 4, 2, is going to point at 6. This dot, it can be 1, okay, what can this dot be? If it's 1, 2, it would point at 3. That's fine. 1, 2 works. 2, 3 doesn't work. 3, 4 doesn't work. 4, 5 would point at that cell, and that would work. 5, 4 would point at that cell, and that would work. So 4, 5 or 5 4 works. 5, 6 doesn't. 6, 7 doesn't. 7, 8 does in one particular order. So 8, oh, this can't be 4 and this can't be 5. 8, 7 would be that cell. No, that cell, and it would have to be 15 minus, it would have to be 6. So it can't be 8, 7. And 8, 9 would have to be 8, 9, which is that cell, which is 17 minus 9 would be 8, and it can't be. So it is from 1 to, so these are the only possibilities. It's either 1, 2, or it's 4, 5. Now, if it's 4, 5, that becomes a 9. And this becomes 7, 8. It can't be 1, 2. Because one of these points to 1, 2. This is 4 and this is 5. So 4, 5 points to 9. This can't be 4, 5. It's 7, 8. 7, 8 now has to point to 6, which means this is the only place left for 2. That's what I was missing. And now this cell, which was pointed to, it doesn't have to be pointed to by one of those, but this cell is one of the options for this, but I don't think 7 was what I got. So if this is 7, 6, 7, 6 is 13, 13 minus 9, this would have had to have been a 4, and it's not. So this is 5, 6, 5, 6 is 11, 11 minus 9 is that's the 2, and that's the 4. Now I've got my 2, 4, so I can't do 2, 4 anymore. So the only ones left are 1, 2, and 4, 2. So these are both 2s, and these are 1 and 4. 2, 4 is done. 7, 8 is done. 5, 6 is done. 4, 5 is done. This is crazy. That was super cool, and it took me a while to see it, for which I don't know if I should apologize, because that was tricky. Now, this is a quadruple, and I'm just going to mark it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 4, 5, 9. Well, there's no 4 in any of those. There's no 5 in any of those. There's no 5 there, so that's a 5. 1, 4, 9? Not sure, but this column is now missing. Oh, the 9 looks down. That's a 1, so this is a 4, 9 pair. So what's this pair? 1, 2, 3, 4, 5, 6, 7, and 8. Okay. What's this pair? 1, 2, 3, 4, 5, 6, 1, and 7. Well, this 7 looks like making that the 1 and that the 7. Now this is a pair. 1 and 2, 3, 4, 5, 6, 7, 8, 9. This is a 1, 2 pair. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a 4, 5 pair. Not resolved. What about this triple? 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, there's no 2 there. There's no 2 there. That's a 7, 8 pair. That's the 2. 2 is not there or there now. So that's the 2. That's the 1. That's the 2. Seven, 8 pair, I'm not sure about. This is crazy. All I know is these need to be different. They need to be different. Because one of them is going to point to 4, 2, and one of them is going to point to 1, 2. One of them is going to point to that cell, and one of them is going to point to that cell. Ooh. 3 is in one of those two cells. 5 is right there. Where's 5 in this box? That 5 knocks out those. That 5 knocks out those. This is the 5, so this is the 3. This is now a triple. 1, 7, and 8. Well, there's no 7 there. There's no 8 in either of those. So that's the 8. This is a 1, 7 pair. This is super cool. So this is a pair. 1, 2, 3, 4, 5, 6, 7, 8. 1 and 9. Surprisingly unresolved. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 5, and 6. Well, there's no 6 there, there's no 2 there, there's no 2 there, so that's the 2, and this is a 5, 6 pair. I'm not breaking this open. I'm missing something. I think it's probably going to have to do with the fact that these need to be different. All I know is that can't be 4. That can't be 4. That also can't be 1. So that can't be 1. So 1 is in one of those 3. So 1 is in one of these 3. Is that cutting it? It just don't cut the mustard. So what is this quadruple? Row 7 is doing weird things. 3, 4, 5, 6, 7, 8. 3, 4, 8, 9. Well, there's no 3 or 8 there. So this is a 4, 9 pair. So I can take 4, 9 out of both of those. The 3, 8 pair. Which again, the 8 here makes that the 3, that the 8. Which has taken the pencil mark of a 3. This is the only place left for a 3. That didn't do much, except there's now a pair here. 1, 2, 3, 4, 5, 6, 7. This is just 1, 4, 7, 9 without... So this is 1, 7, or 9? So what I don't have a 5 in either of those. I don't get it. I don't... 4 is in one of these two by Sudoku. So if this is a 1, this is a 4. If this is a 4, this is wide open. If this is a 1, this is a 4, this is a 4. And that's a 4, and that just works. Ugh. No, this 3 is looking up. That's not 3. This is 3. I've got all the 3s now, so that's not done much. But I've now got a quadruple in this row. 1, 2, 3, 4, 5, 6, 7, 8. 4, 6, 7, 8. Well, that's not 4 or 6 or 8. That's just a 7, which means that's the 8 and that's the 7. I can take 7, 8 out of both of those. These are 4 and 6, but this 6 looks up making that the 4 and that the 6, which looks down making that the 5 and that the 6, but which looks down taking 5 out of there and making that the 5. But this 4 looks down making this the 1, which makes this the 7, taking 7 out of there. The 1 makes that the 9 and that the 4, which makes that the 9 and that the 4. But the important thing to remember is these had to be different. So that's now the 4, which I did have by Sudoku. But this is 5, this is 4. The 1 looks up making that 7, which makes that 1, which means this has to be the 1 in the column. This is triple now, is 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, there's no 7 in either of those, so that's the 7. The 8, 9 pair, not seeing how to resolve it. Not yet anyway. This is a pair. Actually, let's put this 1 in and then look at this pair. 1, 2, 3, 4, 5, 6, 7, and 9. And regret every choice I made about that pair. Need to put a 1 in one of those two for the column, but it's not there, so that's the 1. This is a 7, 8, or 9, and it's not a 7. So it's an 8, 9, giving me an 8, 9 pair. So 1, 2, 3, 4. This is a 5. So this is an 8, 9 pair, but there's an 8 looking up the column. So this is the 9. So this is the 8, this is the 9, which means this is the 8, which looks down making that the 7 and that the 8. The 9 looks down making this the 1 and this the 9, which makes this the 7 and this the 9. And that's the correct solution. 39 minutes and 22 seconds. Solve counter, 69. In 27.6 days. I'm assuming that my chair just did something weird. What is going on? Okay. I'm assuming that that deduction I made at the beginning was logical and correct and sound, because at the time I couldn't, it flowed and the puzzle worked from there, eliminating that digit as a possible target. Now, there was possibly a cleaner way of doing it than the way I found it, but that was really, really clever. And I don't know how well telegraphed it was, but not every puzzle which introduces a concept like this needs amazing telegraphing. If you can find it. I'm very happy with myself with a 40-minute solve time on that one. You may not be happy with a 45-minute video, but I am. That was cool. Thank you very much, everyone. That was cool. That was a very cool puzzle. Thank you, GoodCity, for setting something that stunning. I didn't see when there were only 7 dots how I was going to break into that one. For a while there, I was going, do I have to turn this video off? In the back of my head, I say that almost every video. This was cool. Like this one. Thanks everyone for watching. And as always, good luck with your solving.